My name is Forrest Swope. I'm the manager of data operations for the University of Virginia. My teams support both the academic mission and the medical center enterprise, so we deal with student information as well as patient care. So I was working prior to this job for a company that did semantic processing of our clients are like the AMA and the APA, so we're doing pretty heavy lift on semantic content for these big publishers. And we had a 500,000 element taxonomy that we had hand curated over the last 20 years. And we were doing in-house some processing of like AMA articles against this thesaurus and then assigning them to various different topic categories. And I was working with the director of semantic processing on some point of care products for physicians. So I'm a physician who is going in to see a patient who may have kidney failure, and I don't want to just pull up content that is about kidney failure. I might want to know, well, what are the symptoms I'm looking for? What are the diagnoses that I should be using? Or what would some treatment options be? And the thesaurus got us to the point of this is related, but it didn't describe the nature of the relationship. So we started looking into graph database technology as a way to take all of this content and information that we had and actually impart the meaning by using the edges. So we could say, okay, I need to know, and they would literally put in like DX kidney disease. So they would get back just the articles that reference the diagnostic components. So it was that realization that the important part of the relationship is the meaning of the relationship, not just that it exists. And this looked like a technology that would help us get there. We're interested in pursuing the technology because we have some very complex problems that we want to solve. And my experience in working with data is that relational databases are very highly structured, and because of their grid-like nature, they're great for pulling transactions back or creating long tabulations, but they're not great for assessing more complex relationships, and particularly ones that you haven't explicitly created in the database. So if you haven't set up your foreign key relationships, you may not be able to get at it, even if it, theoretically you would like to. So as an example, the state of Virginia has an interest in supporting community college students who maintain a B average over the first 2 years of college in transferring to the public schools in Virginia. So we have a lot of third-year students who are incoming who are community college students who might not have been accepted as first-year students, and they represent a very different cohort that we're just beginning to learn about, but they have a lot of challenges. They tend not to live on campus. They request access to student services more than other students. They don't have an established network of friends. They don't join fraternities at the same rate. So they have an educational disadvantage and a social disadvantage, and we'd like to explore the successful cohort of students and in that group, and then figure out what is it that they're doing. Are they more connected? Are they doing these activities? How are they choosing to interact with the university and thrive versus the ones who appear to be struggling more and using more of the services? Because we want everybody to be successful. This is not the kind of question I can go to a relational database and try and answer, right? But if I took the information from 50 of my relational databases, then I could build an interesting graph and maybe learn what makes some of these kids do better than others. Yeah, I think the idea of adjacency and being able to unearth the meaning of relationships that would be hard to expose versus relational technologies is really the key to it for me. Again, the relational structure just tends to say X is a Y, but it doesn't tell me what type of Y or what the character of that relationship is, and that's the part that's important to us for solving this exercise. And I think the ability to sort of not know all of the questions you're going to ask, but be able to answer them anyway is really powerful, because with relational, we tend to need to know the questions we're asking before we structure the build. Here, we don't have to.
Is or looks like?
I think it's huge. I mean, some of the other work that we had been doing when I was in scholarly publishing was looking at the affinity of people for certain content, and we were using Kettle and Pentaho and a bunch of adjacent tools to try and solve this problem. But the modeling we were doing was felt somewhat restricted because we were using relational technologies to house the ultimate data and analysis. We were trying to do Netflix-like recommendation engine for scholarly content. So that affinity processing and understanding, again, what the sort of meaning is, just because somebody read the same content as me doesn't mean that I actually have a real affinity with them or their preferences. So how can we distill the information we have in sort of non-traditional ways?